Okay, here's another equation. This is a quartic equation. Quartic because the highest power is 4. Quartic equation in M. So what we're going to do, we're going to use a U substitution. And you're going to use U substitutions a lot in the future. Certainly in calculus, trigonometry, it really does help. And actually, generally, a lot of the time when you use a U substitution, it is for the sole purpose of reducing something to a quadratic equation that you can solve. So in this case, we're going to let U equal M squared, and then we're going to rewrite this whole thing in terms of U, and it's like a dummy variable effectively. It's going to enable us to solve the thing using what we know about quadratics. So, well, if U equals M squared, then U squared is going to be M to the power M squared squared M4, so this is going to become U squared. So if I rewrite this, I'm going to have 2U squared minus 5, well, M squared is just U, plus 2 equals 0. So now it looks like something that's a lot more manageable. I have a quadratic equation in U, everything's already nicely in order. I'm going to try and factorize it. So 2U, U, prime number 2, so it's got to be 2 and 1 somewhere. 2 times 2 is 4, and I'm trying to get to 5, so I think that's going to work. Minus times a minus is a plus, and then I want the negative here, so something like that. So U equals a half, or U equals 2, right? But remember, the equation isn't asking me what U is, it's asking me what M is. So now you can substitute back in. So M squared equals a half, or M squared equals 2. So that would mean that M equals plus or minus square root of a half, or M equals plus or minus root 2. Now, I know what you're probably thinking, why now is he suddenly doing plus or minus signs? Well, now we've got a quartic equation. So degree 4, you would expect 4 answers. A quartic equation, something with degree n, an equation, should have n answers. So I'm not going to get 4 answers if I only consider positive answers. So the square root of a half is 1 over root 2. So M equals plus or minus 1 over, I'm going to write it over here. M equals plus or minus 1 over root 2, or M equals plus or minus root 2. Now, I don't like that 1 over root 2, I'm just going to rationalize it. So M equals plus or minus, so you rationalize by timesing by root 2 over root 2. So 2 So you rationalize the thing by timesing it by root 2 over root 2. So M equals plus or minus root 2 over 2, or M equals plus or minus root 2. Now, I probably should check these answers in the initial equation. So basically you need to check if when M equals minus root 2 over 2, or root 2 over 2, is 2m to the power 4 minus 5m squared plus 2 is 0. Now, because you're raising the number to the power 4, and you're squaring a number, and then the 2 is going to be the same in either, you only actually have to check the positive version. Because when you raise something to the power 4, the answer is going to be positive, unless you're dealing with complex numbers, which we don't know about yet. And if you raise something, if you square a number, you're going to have the same thing. So we literally, that saves us half the work. So when M equals root 2 over 2, so 2m4 minus 5m squared plus 2, well, that equals 2 times root 2 over 2 to the power 4 minus 5 root 2 over 2 squared plus 2. Now, that is a bit of a pain. New board. Well, root 2, so equals root 2 to the power 4. Well, root 2 times root 2 is 2. Root 2 times root 2 is 2. Times them all together, 2 times 2 is 4. So you end up with 2 over 2 times 4. That's the root 2 to the power 4. Over, well, 2 to the power 4 is 16. Minus 5. Root 2 squared is 2. 2 squared is 4. Plus 2. So, this is 8 over 16 is a half, right? Oh, dearie me, so. Minus 5 times a half, so that's 5 halves, plus, well, 2 must be 4 halves. So 1 minus 5 is minus 4, plus the other 4 equals 0. So that's showing me that plus and minus root 2 are solutions. Okay, so the next one, when x equals root 2, should be easier. When m equals root 2, 2m4 minus 5m squared plus 2 equals, so 2 times root 2 to the power 4, which we've already established was 4, minus 5 root 2 squared plus 2 equals root 2 times root 2 times root 2 times root 2 is 2 times 2, which is 4. 4 times 2 is 8. Root 2 times root 2 is 2, times the 5 is minus 10 plus 2. So that is 8 minus 8 equals 0. So that is showing us that m equals plus or minus root 2 are solutions. So solutions are confirmed. So it's minus 2, try that again, minus root 2 over 2, root 2 over 2, minus root 2 and root 2.